Good morning, students. In the previous class, we had discussed about the concave mirror and convex mirror, the image formation in the concave mirror and convex mirror. What are the uses of concave mirror and convex mirror? That all are discussed in the previous class. In the today's session, we will discuss about the refraction of light. What the way the light will be refracted, that it will be explained in this session. Okay. Then first enter this topic. Let's enter this topic. First, you should know about what is speed of light. How will you calculate the speed of light? Speed of light is nothing but light will be moving, having some speed, having some velocity. Any one thing it will be moving, having some speed. So speed of light means the light will be moving from one medium to another medium, having some speed. How will you calculate the speed of the light? In the year of 1564 to 42, Galileo Galilei will be discovered the speed of light, will be analyzed the speed of light, will be giving the value of 220 near 220 2 point something to 10 power 8 meter per second near, it will be giving the value. So in the year of 1564 to 42, Galileo Galilei they analyzed the speed of light, and then in the year of 1665 Roma he did the experiment to explain the speed of the one planet, one star, not a planet, one moon among the 12 moons of Jupiter. Jupiter la 12 moons la oru moon oda speed analyze pannirkaru early Roma. He did that experiment to analyze the speed of the light to be passed on the moon. He checked the speed of the light is 2,20,000 km per second. Okay, so Holy Roma will be give the speed of the light value is 2,20,000 km per second. Next, 1849 Airman VIDHYA, it will be analyze the speed of the light, it will be giving the value 3 into 10 power 8 meter per second. So speed of the light, it will be having some value, that the value is 3 into 10 power 8, that is the final value, will be given by Airman VIDHYA. Okay, so in the 1642 Galileo Galilei, it will be analyze the speed of the light, and 65 early Roma he analyzed the one moon among the 12 moons of the Jupiter, will be giving the light will be passing on the moon and the Jupiter, and then the speed of the light is 2,20,000 km per second, and 1849 Airman VIDHYA will be giving the value of speed of the light 3 into 10 power 8 meter per second. Okay, that all are the speed of the light. How will you calculate the speed of the light? Speed of the light, the value will be given by the various scientists. That is all are the values of speed of light is given by the various scientists. Next, we will go for the refraction of light. What is the refraction of light? Already told, taking one glass halfly filled with the water, one pencil will be put to the inside of the water level, the upside of the water level and downside of the inside of the water level, you have to check. The pencil portion will be slightly changed, that is called refraction. Okay, so refraction, mostly refraction will be done from the light will be passing from one medium to another medium. One medium la innor medium ku pona da refraction possible. Okay, so refraction taking denser medium and rarer medium. Denser medium means density higher medium. Density higher medium is denser medium. Density lower medium they are called rarer medium. So denser medium and rarer medium, taking the denser medium and rarer medium. Okay, mostly rarer medium is called air. Air is the rarer medium. So light will be passed on from rarer medium to denser medium. Light it will be passed on from rarer medium to denser medium. This is a normal line. Okay, so rarer medium to denser medium ko light fall agudnu vechukonga. Rarer medium to denser medium just bends towards to the normal line. That is a normal line. Bends towards to the normal line. So light will be passed on from rarer medium to denser medium. Rarer medium வந்து denser medium நோக்கி ஒரு லைட் போகுது அப்படின்னா, rarer medium வந்து ஏர்ல இருந்து ஒரு கிளாஸ்க்குள்ள ஒரு லைட் போகுது அப்படின்னா, just spins towards to the normal line. Normal line நோக்கி bend ஆகும். Okay, just the light will be falling from denser medium to rarer medium. Light will be falling from denser medium to rarer medium, just is move away from the normal line. Normal line விட்டு அங்கிட்டு போகும். Okay, so light will be passed on from rarer medium to denser medium, spins towards to the normal line, and denser medium to rarer medium, it will be bends away from the normal line. நார்மல் லைனை பக்கத்தில் போச்சுன்னா அது வந்து ரேராக மீடியம்லேருந்து டென்சர் மீடியமுக்கு போயிருக்குன்னு அர்த்தம். ஓகேவா? ரேரானா ஒன்றும் இல்லை, டென்சிட்டி கம்மியாக உள்ள மீடியம். denser medium means density, the medium having the greater density. Okay, so laws of reflection. What are the laws of refraction? Already I explained the laws of reflection. In this portion, laws of refraction. Laws of refraction means first one, normal line, incident ray and refractor ray all are lying in the same plane. All are lying in the same plane. Lie in same plane. ஒரே பிளேனில் இருக்கும். All are lying in same plane. Okay, and then second one, just obey the Snell's law. Obey Snell's law. Obey the Snell's laws. What is Snell's law? Mu's 1, 2. Light will be falling from one medium to another medium. Mu is the refractive index. Refractive index is the ratio of the speed of light will be passing from one medium to another medium. ஒரு மீடியம்லேருந்து இன்னொரு மீடியமுக்கு லைட் ஃபால் ஆகும்போது அதுக்குள்ள ரேஷியோ தான் refractive index. So refractive index mu from the light will be passing from one medium to another medium will be equal to ratio of sine of the angle of incident to the sine of the angle of refraction. So mu is equal to sin I by sin r, that is Snell's law. So one light will be obey the Snell's law, that is the definitely the refraction will be done by the light. Okay, so refraction of two laws is there. One is normal line, incident ray, refractor ray all are lying in the same plane. Second one, refraction of light will be obey the Snell's law. Snell's law is equal to mu is equal to ratio of sine of the angle of sine of incident, sine angle of incident to sine angle of refraction. Okay, mu is equal to sin I by sin r. Then mu it will be equal to refractive index mu is equal to velocity of light in air to velocity of light in medium. So ratio of velocity of light in air to velocity of light in medium. Another one formula, speed of medium, speed of the light in one medium to speed of light in another one medium. ஒன்றும் இல்லை, ஒரு மீடியம்னு இன்னொரு மீடியமுக்கு போகுது அப்படின்னா அந்த ரெண்டுக்குள்ள ரேஞ்சுக்கு பேர் தான் refractive index. So refractive index is nothing but speed of light in air to speed of light in medium, and then speed of light in one medium to speed of light in another one medium. So that is called refractive index. So refraction, what are the laws of refraction, and what the way the light will be bends, refraction will be bends towards the normal line and away from the normal line. And then what is meant by refractive index? What is Snell's law? Sin I by sin r. Okay, mu is equal to sin I by sin r, it will be called as Snell's law. Mu is equal to speed of light in air by speed of light in vacuum, speed of light in medium, and then ratio of speed of light in one medium to speed of light in another one medium. That all are called refraction of light. Next we will go for total internal reflection. Total internal reflection is a very important detail, that is TIR ன்னு சொல்லுவாங்க. Total internal reflection. What's the meaning? That heading giving the answer, totally the reflection it will be done internally. Internally the reflection will be done, that is called total internal reflection. So I explained that one example, light will be falling from denser to rarer. Okay, this is the normal line. This is the normal line. Light will be falling from denser to rarer. Okay, so below the angle of 90, angle of 90 விட கம்மியாக இருந்தது லைட் பாஸ் ஆகக்கூடிய ஆங்கிள் 40, 60 அந்த மாதிரி இருக்குன்னு வச்சுக்கோங்க. The below the angle of 90 refraction angle is below the 90, just bends away from the normal line. Light it will be just bends away from the normal line. At the angle of 90, it will be crosses the mean position of the normal line. Cross the mean position. Mean position போய் just படுத்துரும். Below 90 இருக்கும்போது வெளியில் போய் ரிஃப்ராக்ட் ஆகிட்டே இருக்கும். At the point of 90ல ஜஸ்ட் அந்த லைனில் போய் க்ராஸ் ஆகிரும். தென் higher 90 விட அதிகமாக இருக்கும்போது it will be totally internally reflected. No refraction is there, only totally reflection only is there, it will be internally. இன்டர்னலாக மட்டும் ரிஃப்ளெக்ஷன் நடக்கும். இது பேர் தான் total internal reflection. So what's the condition to create the total internal reflection? Only the light will be passed on from the light it will be passed from denser to rarer. Denser medium rarer medium light fall out. One condition, the light will be falling from denser to rarer. And second condition, angle of incidence definitely will be greater than the angle of critical angle. Critical angle means angle of incident, it will be less than 90. 90 விட கம்மியாக இருக்கும்போது refraction மட்டும்தான் நடக்கும். Refraction only done. Okay. Angle is equal to 90. That is called critical angle. At a particular angle, the ray it will be does not to be refracted and does not to be reflected. Reflection ஆகாமல் refracted ஆகாமல் just அந்த லைன்லேயே படுத்துருச்சு அப்படின்னா அது called critical angle. As a which angle the light cannot travel to the another one medium and does not to be reflected. Just bends in the normal line. As bends the equilibrium position. That is called critical angle. So second condition is angle of incidence definitely is greater than the critical angle. So is greater than 90, automatically the ray will be reflected to the inside. Total internal reflection ஒன்றும் இல்லை, ரிஃப்ராக்ஷனே நடக்காமல் உள்ளேயே ரிஃப்ளெக்ட் ஆகிறது பேர் தான் டோட்டல் இன்டர்னல் ரிஃப்ளெக்ஷன். இந்த மீடியம்லேருந்து இன்னொரு மீடியமுக்கு போகாமல் இந்த மீடியம்குள்ளேயே ரிஃப்ளெக்ட் ஆகிறது பேர் தான் டோட்டல் இன்டர்னல் ரிஃப்ளெக்ஷன். எந்த கண்டிஷனில் அது டோட்டலி உள்ளே ரிஃப்ளெக்ட் ஆகுது, ஆங்கிள் ஆஃப் இன்சிடென்ட் வந்து 90 விட அதிகமாக இருக்கும்போது, ஆங்கிள் ஆஃப் இன்சிடென்ட்ஸ் இங்கேருந்து போகக்கூடிய லைட் 90 விட அதிகமாக இருந்துச்சுன்னா இட் வில் பி டோட்டலி இன்டர்னலி ரிஃப்ளெக்டட். Okay, what are the condition to be explained that the light will be definitely travels from denser to rarer and angle of incidence will be definitely be greater than the critical angle. So that are the two conditions will be used to explain the total internal reflection. Then one application is there, diamond, it will be shining on the basis of total internal reflection because the light it will be totally internally reflected to the diamond part. More cutting is there, so it will be brighter. Then mirage, already you know that mirage means conally, in Tamil conally. Some in the summer days you see the road, some water body is there, it will be appear to some water body is there because in the hot summer season the road temperature, road near air it will be very hotter than the upside air. So the hotter air having less density, so less density having small refracting index. So refracting index will be small, automatically the reflection only done totally internally. அதாவது சம்மர் சீசனில் நீங்கள் ரோடு பக்கத்தில் இருக்கக்கூடிய ஏர் வந்து ரொம்ப ஹாட்டாக இருக்கும், மேலே இருக்கக்கூடிய ஏரை விட. இந்த ரோடு பக்கத்தில் இருக்கக்கூடிய ஏர் ஹாட்டாக இருக்குன்னா டென்சிட்டி கம்மியாக இருக்கும், வெயிட்லெஸ்ஸாக இருக்கும். அப்படி இருக்கிறதுனால அதோடைய ரிஃப்ராக்டிவ் இண்டெக்ஸ் வந்து ரொம்ப கம்மியாக இருக்கும். ரிஃப்ராக்டிவ் இண்டெக்ஸ் கம்மினாலே ரிஃப்ராக்ஷன் நடக்காது, ரிஃப்ளெக்ஷன் மட்டும்தான் இருக்கும். ஸோ டோட்டலி உள்ளேயே ரிஃப்ளெக்ட் ஆகும். அப்படி ரிஃப்ளெக்ட் ஆகும்போது நமக்கு அதில் இருக்க வாட்டர் தெரியும், வாட்டர் இருக்க மாதிரி இருக்கும். இட் இஸ் கால்ட் மிராஜ். So that all are the example for total internal reflection. Total internal reflection is only done, the light will be passing from denser to rarer and then angle of incidence will be greater than 90, critical angle. Okay, and then last is optical fibers. Optical fibers will be completely working on the basis of total internal reflection. So what's the phenomena, what's the principle it will be used to working of optical fiber, that is called total internal reflection. Okay, so optical fiber having two, one is core, another one is cladding. Optical fiber will be having this structure, so two sides open is there, that is called core. Okay, in the center part and by having cladding. So the core having high refractive index and cladding having low refractive index. Okay, the light will be passed on from one side, core having high refractive index. So only totally internally the light will be reflected, that the both sides, two sides only will be giving the reflection and center side totally internally reflected. Fiber optics அப்படின்னா ஃபைபரால் மேக் பண்ண ஒரு டியூப், அந்த டியூப்பில் நீங்கள் லைட்டை பாஸ் பண்ணும்போது ஒன் சைட்லேருந்து இன்னொரு சைடில் லைட் போகும், பட் சென்டரில் எந்த வியூவுமே தெரியாது, ஏன்னா அது உள்ளே ரிஃப்ளெக்ட் ஆகும். இந்த பேலன்ஸ் இருக்கக்கூடிய ரெண்டு சைட்லையும் உங்களுக்கு வந்து லைட் வந்து தெரியும், அதுக்கு தான் டோட்டல் இன்டர்னல் ரிஃப்ளெக்ஷன். So total internal reflection, optical fibers having core and cladding. Core is the edges point and cladding is the center point. இந்த edges pointல தான் refracting index ஹையாக இருக்கனால இங்கே மட்டும் லைட் வியூ தெரியும், இங்கே ரிஃப்ளெக்ஷன் மட்டும் நடக்கும் உள்ள சென்டர் பாயிண்டில். That is called optical fibers. What's the use of optical fibers? Optical fiber it will be used to transmit the audio and video signals to the long distance. Long transmissionக்கு audio and video signal கொண்டு போகிறது optical fibers. In the mobile communication, automatically the fiber optic communication only used. Then surgery. So optical fiber will be the easily flexible one. So it will be used to in the laser treatment. லேசர் ட்ரீட்மெண்ட் இருக்குல்ல, அதில் வந்து அந்த பைப்ஸை யூஸ் பண்ணி பைப்பை மட்டும் உள்ளே விட்டு எண்டோஸ்கோப்பி இதில்னா வந்து ஹோல் சின்னதாக ஹோல் போட்டு அந்த பைப்பை மட்டும் உள்ளே விட்டு it will be used to treatment of as a perfect surgery. It will be treat the tissues, tumors in the stomach or other parts. So it will be easily flexible, it will be easily perform the surgery. Okay, so optical fibers it will be used to in the two ways, audio video signal transmission, and second one is performing a surgery. So optical fibers it will be completely working in the principle of total internal reflection. In the core part refractive index ரெண்டு சைட்லேயும் கோர் இருக்கும், அந்த டியூபோடே இந்த சைட்லேயும் கோர், நடுவில் இருக்கிறது கிளாடிங். கோர் பார்ட்டில் refractive index ஹைங்கிறனால அந்த இடத்துல மட்டும் உன்னோட லைட்டோட வியூ தெரியும். சென்டர்லி the refractive index value is less, so light will be reflected inside, so no light will be viewing at the outside. So that is called optical fibers. In the today's session I explain what is speed of light. Speed of light means light will be traveled from one medium to another medium, definitely having speed. So that is called speed of light, and some scientists is giving the various values, and last 1865 Airman Physia will be giving the speed of the light. The value is 3 × 10⁸ meter per second. Okay, then refraction it will be only done from one light will be passing from one medium to another medium, denser to rarer. Okay, so denser to rarer to denser, the light will be bends towards to the normal line. Denser to rarer, the light will be bends away from the normal line. So okay, laws of refraction, one normal line and incident ray and refracted ray all are lying in the same plane. Second one, it will be obey the Snell's law, mu is equal to sin I by sin r. Mu is equal to speed of light in air by speed of light in medium, and mu is the ratio of speed of light in medium one to speed of light in another one medium. And then third one is total internal reflection. Total internal reflection means light will be falling from denser medium to rarer medium below the angle of 90 degree. 90 degree is the critical angle. Below the angle of 90 degree, the reflection will be done from denser to rarer. It will be just bends away from the normal line, and the angle of 90 degree, this is the critical angle, that the angle of 90 degree, the light it will be crosses the center line, that's the even mean position, and the greater than 90 degree angle of incidence is greater than the critical angle, not to be refraction not to be done in this at this angle, reflection only possible, and that the reflection will be called total internal reflection. So condition for total internal reflection is must the light will be travels from denser to rarer, and second one, the angle of incidence must greater than the 90 degree critical angle. Okay, and fourth one is fiber optics or optical fibers. Optical fibers is having the fiber plastic, and two parts is there, one is core, another one is cladding. Core having the refractive index high than the cladding, and then uses of, so the core part only the light will be refracted, and the middle part light only reflected because the refractive index will be low. Then uses of optical fibers is transmission of audio and video signals by the way of optical fibers, and surgery it will be easily flexible one, so it will be easily perform the surgery. Okay, then Narendra Kabani is the father of optical fibers. Who is a scientist, it will be coming from the, this is the he is an Indian born scientist. It will be he is the father of the optical fibers. Okay, so today home assignment, learn and write the home assignment. Learn and write the total internal reflection. Total internal reflection. Learn the detail, ma. So learn the detail. Learn and write the total internal reflection. Okay, thank you.